Hello, and welcome to Team Honeycomb's Team Teaching Android in Action Chapter 3. On the following slides, I'll be talking about topics that were assigned to Team Honeycomb by Dennis Moll. Our first topic is Android View classes. The Android View is the base for many classes. The View class provides a wide range of classes, such as Edit Text, Spinner, and Text View, to specialized widgets such as Analog Clock, Gallery, and Video View, just to name a few. As evident from Figure 3.4, many views are descendant of the view class. The figure shows how these specializations fan out as well as some of the view-derived classes. The view class is the basic building block for user interface or UI components by using view and view group objects. The view class is the base for the widget subclasses, which offers UI objects like text fields and buttons, while the view group class is the base for subclasses called layouts. Figure 3.4 shows a class diagram of the Android View API, as you can see how the specializations fan out from the View class. The view-based class methods allow for UI-related operations such as setting the background, height and width, padding, layout parameters, and event-related attributes. Table 3.3 is an example how the TextView subclass has refined methods for setting alignment, gravity, height dimension, text, and typeface. By combining the view-based class with the TextView methods, it provides extensive control over how an application can manipulate an instance of the TextView. The next topic, common layouts. When designing user interface, specifically the screen that will interact with the user, there must be a layout of sorts in order to place components such as buttons, text, labels, and so forth onto the screen. All layouts are child/subclass of view group. Layout of the screen is defined by two objects, view group, layout params. View group is a particular view that contains other views. Container defines and provides access to layout. Layout params defines a set of attributes of a view. For example, in Figure 3.6, frame layout has layout params gravity. Layout params dimension, as in width and height, can have one of three to be defined by 1. A set number like 200 pixels wide, 2. Fill parent. Fill parent means that this layout or component layout will fill without padding. 3. Wrap content is the opposite of fill parent, as in it fills with padding. Here are common layouts. Note, they are child of view group and all inherit height and width from parent view group, as shown by Figure 3.6. Frame layout, which is the most simple layout, holds a single object that is positioned absolute in the top left corner. Linear layout aligns all objects in a line, vertical, or horizontal. Table layout aligns objects by columns and rows. Relative layout aligns in accordance of position to parent view or another view. Layouts can be nestled. Implementing layout. Choose a layout and write it in XML. Then define attributes and components to be used in a created XML file in the res/layout directory. Example, lining up a button and text in a line in the created XML main_layout.xml file. The sample code below shows you how to line up text in a line. The top code here shows you how to line up text in a button. Then you use the setContentViewInt method to load the layout file for the activity, specified by the resource ID. Example, setContentView r.layout.main_layout. Note, view elements have two sets of height and width. One set, they are defined getMeasuredHeight, getMeasuredWidth by themselves, and the other set, the parent defines getHeight and getWidth, them. There is a hierarchy when drawn on screen. Parents go first, then child. Figure 3.6 shows the inherent relationship between view group and the layouts. Our next topic is two halves of an event. Events are used to change the focus and for many other actions. Only one component can be focused at a time. For example, on-click listener. Events have two halves, the component raising the event and the components that respond to the event, aka observable and observer, or subject and observer. Observable notifies all the observers when something has happened, event. Then the observer responds to the notification. The following represents the two halves of on-click listener example with Figure 3.7, the observable button and the observable listener. Figure 3.7 is a class diagram depicting the observer design pattern. Each observable component has 0 to many observers, which can be notified of changes when necessary. Relationship between Android views and the two halves of an event. Observer view items can be classified as observable and observer. Android view items that begin with quote on end quote are observable items or event related. The rest are more or less observers. However, observers aren't limited to just UI objects. Important aspect to Android view interface is single-threaded. The next topic is the strings.xml file. The strings.xml file is an XML file that is used for externalizing string literals from code. This allows you to store and update the value components without having to do it in other files, such as the reviewcriteria.java file. For example, let's say that your application has 3 activities. If you had just created Java objects within each activity and gave values to specific components, you would create more work for yourself. An easier way would be to create an XML layout file for each activity and use references to string values of specific components. Since we are focusing on the strings.xml file, let's look at the following statement that can be found within this file. The string name equals getViews button label, getReviews, and string. The getReviews button label is the reference file found in the layout file, and the getReviews is the string file, or string value, Note, the format used in this file is called simple value in Android terminology. For example, above, you'll see that there is a string element with a name attribute for the getReview button string. This is the standard format for each string value that you define within the strings.xml file. You'll be basically referencing the string value in your activity and layout file. Whenever the user wants to change the string value of a component, all they will need to do is go to the strings.xml file and change the string's value. This file can be found within the source folder at the res/values/strings.xml location. Now let's review what I've gone over in the previous slides. The Android view is the base for many classes and the building block for many UI components such as widget and layout. Layout is the child class of view group and can be defined as layout params and view group. Layout params defines a set of attributes of a view, as view group is a particular view that contains other views. Inheriting from layout params is common layouts such as frame layout, linear layout, table layout, relative layout. Layouts can be nested within another layout. Events can be used to change focus or to do other actions. Events have two halves, the components raising the event and the components that respond to an event, aka observable and observer, or subject and observer. Observables listens for an action and notifies observer components. Observer components react to the notification. The strings.xml file is an XML file that is used for externalizing string literals from code, which allows you to store and update the values of components without having to do it in other files. This file can be found within the source folder at the res/values/strings.xml location. Well, this concludes Team Honeycomb's Team Teaching from Android in Action, Chapter 3.